Day 1. So here's your notes packet for Unit 1. This unit is all about equations. We're going to start with expressions today. It's about equations and inequalities and solving. Hopefully, the stuff we're going to do today and even Friday, we have seen before. Okay, that's the goal here. Hopefully this is a little bit familiar. We know it's been a summer. We all need a little bit to adjust. So today we're just going to be working on section 1.1. So if you'll go to page 2, we're going to work through some of these problems. I'm going to do some with you, let you do some on your own. We'll check answers, make sure we're all good to go. And then I have a little practice sheet after that. That's it, okay? So one thing that I'm really working on this year is vocabulary, math vocabulary. One thing that I feel like my students have said in the past is when they get to the STAR test, it's some of those STAR questions, just the way they are worded and the vocabulary that it uses sometimes can make a question that I know you can do, but you just aren't sure what the question's actually asking. So we will be really, really hammering STAR questions throughout the entire year as we get to new units, so to try to familiarize you with that. But vocabulary is really, really important. So I put some definitions up at the top, and the first thing is about an algebraic expression, okay? So algebraic, you know what algebra is, we get to math with letters. And everybody's like, well, why do we have to put letters in there? I don't know, just it. I didn't make it up, I just teach it. Okay, but an expression, I really want us to know the difference between an expression and an equation. Does anybody know right now what makes those two separate? Expression versus equation. Yes, ma'am.
I'm just going to go for it. I think an expression is kind of like a simpler way of like putting an equation together, but then an equation I think is like when you have to actually solve it, but in
have equal signs, okay? So here's kind of a formal definition. Mathematical phrase containing numbers and or variables. An expression does not contain an equal or inequality signs. We'll talk about inequalities next time, but those are your less thans, greater thans. Okay, you can simplify expressions by combining like terms. Hopefully that is something that's familiar. So anything that two plain numbers, constants are what we call those. Two things with x's, two things with y's. Those are our like terms. Putting those together and or using the distributive property. So let's pick a couple in this first group to kind of do together. You can try some on your own, and then we'll talk about distributive property pretty soon. So let's look at number 1. So number 1, again, this is an expression. Do you see an equal sign?
No.
So we're not getting a number. We're just getting something that is smaller. We're trying to condense it. Right now we've got 2 terms. How do I know that there's 2 terms? What's the first term?
Negative
3p, and then 6p. So terms are separated by pluses and minuses. So right now we have 2 terms. But what do both of those terms have? What do they have in common? They both have p's. They both have variables, the same variable, exactly the same, okay, just a p. So because those both have p's, we can call them like terms. I like to underline, so anything that has a p, I'm going to put it underlined on number 1, which is just those 2 things. And then I can combine them because they are like terms. Now when we combine like terms, we take those numbers in front, coefficients. Anyone heard that word before? Coefficients are the numbers in front of the variables. So what's my coefficient on the first term? -3. What's my coefficient on the second term?
6.
So I'm going to add those together. Those negative signs are important. Minus signs, those are the same thing. You got your graphing calculator if you need to, especially with the negatives. Take note, there's a difference between a negative and a minus. So since the -3 is first, we have to use the negative sign down here. Do y'all see what I'm pointing to? Down here by the decimal point. So -3 plus the other coefficient is 6. Did I put a variable in my calculator?
No.
Do we ever put a variable in our calculator? No, not unless we're in y equals. So all we have to do is take those coefficients, the numbers in front, add them up. What do we get? 3. So what does that mean our answer is? What makes them alike? P. And I like to put a box around my final answer so I know it's my final answer. Okay? Again, I'm not putting in equals anywhere because I don't have an equation. I'm just kind of saying, hey, this is my next level. This is a little bit simpler. Nothing else to do. Once you get to where you have one of each type of like term, you're good to go. Okay, let's talk about number 3, and then I'm going to have you guys try 2 and 4 and 5. I'm going to talk about number 3 really quick. How many terms do we have on number 3?
2.
2 terms. What's the coefficient of the first term?
7.
What's the coefficient of the second term?
1.
1.
What kind of one? A negative. Okay, do you see how that minus sign in between? Minus is telling you that's a negative coefficient. It's not minus a negative, but when you put them together, you can think of it as a negative. So are these guys like terms?
Yes.
How do we know?
Because of the minus sign.
They both have it. Well, not the coefficients, it's the variable. They have the same variable. So I'm going to underline them, and then I'm going to use the coefficients. I'm going to put those together. So my first coefficient is a 7 plus my second coefficient we said was a negative 1. If you do 7 minus 1, that is okay too. Sometimes I like to just be consistent, especially if you're doing multiple negatives in there. It's always you're adding those numbers together. If there's a minus, just know that means it's negative. 7 plus negative 1, what's our simplified coefficient? 6, and then don't forget to put the like term, x. Done. To try 2 and 4 and 5. And then we'll reconvene. Number 2, you've got a couple things to do. So try those, and we'll go over them, and then we'll move on. Okay, I'm going to jump in and talk about number 2 real quick. If you're already done with number 2, please just stay quiet. If you were a little bit confused, let's talk about that here, okay? Shh. If you got number 2, just stay quiet, okay? Number 2, there are 2 sets of like terms, okay? How many terms are in this original guide? 1, 2, 3, 4, okay? But if I look at the first one, what's the coefficient of the first term?
1.
1. Helps to write that in. Don't have to, but you can. I drew my circle too big. Okay, 1b. Now, I'm going to put an underline under that because it's a b. And then I'm going to look at the rest of my terms. Does this guy have a b? Look at what I'm pointing to. Does it have a b?
No.
Does the next guy?
No.
Does the next guy?
Yes.
Yeah.
Yes. What is the coefficient of that term?
2.
What kind of 2?
Negative 2.
Negative 2. So I underlined both of those because they're like terms. They both have a b. Okay, so then I'm going to go to my calculator or mental math it. That's fine too. And I'm going to add up those coefficients. I'm not going to type the letter. We don't type letters in calculators, not in this screen. And I'm going to do 1 plus negative 2. Could also type 1 minus 2. I like to keep it consistent, and I always add. You do you. Okay? 1 plus negative 2 is what number?
Negative 1.
Negative 1. Now, don't forget, what made these guys like terms?
The B.
The variable. Does the variable change when we're adding or subtracting? No. It will eventually. Next semester, it's going to be a fun time. Okay? So here's your first term. Are we done? Are we simplified all the way? We got the other guys. Do you see how this negative 3 and positive 6, do they have variables at all? No. But they're both plain numbers, right? Right? They are like terms. I'm going to circle those guys. Negative 3, positive 6. I'm circling those that even though they don't have a variable, they're plain numbers. We call those constants. Have you heard that before?
Yes.
A lot of vocab, I know. Constants, we can add those together just like we did the coefficients. So what is negative 3 plus 6? 3. What kind of 3 is it?
Positive.
Positive, so I'm going to put a plus 3. Lost you? Okay, so I'm going to put a plus 3 right there. What if I had a negative 3? What sign would I put in the middle?
Negative.
A minus sign. Okay, question. This is a perfect answer. This would get you full credit, 100%. Is this right also? Is that a right answer?
Yes.
Yeah. What did I do differently?
You just did the 1.
I didn't write the 1. Is this a right answer?
No.
No. Is this a right answer?
No.
You sure?
Actually, yes.
Is the 3 positive?
Yeah.
Is the B negative?
Yes.
It's okay. I mean, I wouldn't go flip-flopping every single time, but these are all acceptable answers, and I would count all those right except for that one. That would be a wrong answer. So you don't need to write all 3. I'm just trying to show you. Sometimes the STAR test will do crazy stuff and put different things on there. All right, what about number 4? 7p minus 10p. You got that one?
Negative.
Negative 3p.
Negative 3p. Done. All right, number 5, kind of a trick. Is there anything to do on number 5?
Yeah.
Any like terms on number 5?
No.
No. Only one constant. Remember, constant's a plain number. So nothing to add up to the 9. Only one r. So I'm just going to drop the positive 5r. Only 1p. Nothing to do. There's your answer. Kind of a tricky question, but really no work. Okay? The answer is the question. I typically am not going to give you something like that on a test, but I just want to show you that sometimes it just works that way. All right, let's look at number 6. I'm almost done talking, and we're going to get into just practice now because at this point, we're getting pretty close. Here's what we're going to do. We're going to do 6, 8, and 9 together, and then I'm going to cut you loose. Okay? So, what visibly in this expression, why is it an expression? What does it not have? No equals, okay? In these expressions, though, there's something different. What is it? Parentheses. What's that word? You distribute. When you have a constant, a plain number, or even a variable, we'll get there. In front of parentheses, we're going to use our distributive property, okay? What operation do we do when we distribute? Multiplication. Now, what's outside of the parentheses, if you did the little like rainbow thing, that's fine, but I want you to know that that's distributing, okay? So you're going to take what's on the outside and you're going to multiply to everything inside. That can be one thing, that can be 2 things, that could be 10 things, okay? And that's what our distributive property is. If we have parentheses, y'all remember PEMDAS? If you have parentheses in your expressions or equations, that is priority number 1. What does the P stand for in PEMDAS? Parentheses. You do that before the adding and subtracting. So this is always step number 1. So let's do this one together. Distributing means we multiply. What is 4 times x? 4x. Very good. Then I got to multiply, distribute 4 times positive 2. What is 4 times positive 2?
8.
Is there an x on it? No. Okay. Are we done?
Yep.
We got something with an x, and we've got a constant. Can't combine those. Finish. Put a box. Do. Okay. This is called our distributive property. Distributive property. We're multiplying there. This is a big one in Algebra 1. Actually, all the algebras. I also teach advanced algebra 2, so I know where y'all are going, and I know what's important for when you get there. All right, we're going to do number 8. Let's do number 8 together. Do we have distributive property on number 8?
Yes.
How do I know? Parentheses. Okay, so here we go. The number outside of the parentheses, that constant, is a negative 2. I'm going to bring that in, multiply it to the parentheses. Do I bring that negative 2 to that plus 4 outside?
No.
Why not?
Because it's not in the parentheses.
It's not in the parentheses. Now, we can't just forget about that plus 4, but we're going to follow PEMDAS, and we're going to take care of the parentheses first. Be careful, the 2 on the outside is negative. Negative 2 times positive 7 is what? Negative 14. Negative 2 times negative n. What's a negative times a negative?
Positive.
A positive. What can you write in front of that n if you needed to know what to type in your calculator? You could put a 1, okay? And it's like a negative 1. So you could type negative 2. And this is a big one, is the negative times a negative. That's a big one that comes up on STAR. So be very careful with that. So I end up getting positive 2, but what has to go next to it?
2n.
2n. Very good. We're just kind of bring that variable down.
How would it be positive?
A negative times a negative becomes a positive. We're multiplying when we distribute. Okay? You will get a lot of practice with that because that's a pet peeve of mine. Am I done now?
No.
What else is going on?
Plus 4.
Plus 4. Am I done now?
Yeah.
No.
What do we have to simplify?
The 4 and the 14.
The 4 and the what kind of 14? Negative 14. So you got to be careful with these like terms here. Sometimes you're going to see they get into multiple steps. Sometimes you multiply and you're done. Sometimes you add and you're done. Guess what you're going to do most of the time? Both. Multiply, then add. Now, the only thing we can add here is the negative 14 and positive 4. What does that give us?
Negative 10.
Negative 10 plus 2n. Could you write it like this? 2n minus 10. Is that okay too?
Yes.
Is the 2n positive? The 10 negative?
Yes.
Both are okay. I'm going to write or in between here. Either one works for me. Sometimes I just go in order left to right. Sometimes I put the variable
Could you
first.
simplify more though?
How so?
You divide the 10 divided by 2, and then it would be 5 equals n.
You're ready for second semester.
Close to that, but you can't do that, yeah.
Little, we will get there, but for now we're going to stop right here. Okay, when we're in our simplest form, we're just going to have like no parentheses and stuff there. All right, one more I want to do with you, and then like I said, you've got a couple on this page, a couple on this page, and then I have another practice sheet that you can work on with your groups. But I just want to go over one like number 9, okay? I see parentheses. When I see parentheses, what is my brain saying?
Distributed.
Yeah, first.
Distributing, okay? Do it first. Yes, both of those. However, is there a defined constant, plain number in front of that parentheses?
Yes.
Wait, what?
Is there one written down?
Yeah.
I don't see one written down right here. Can you write one down?
Yes.
What would you write?
1.
A 1. Now, what's important? Okay, hold on. Between the negative 4, there is a minus sign. So that means there is an understood what kind of 1, since there's a minus in front of it. That means it's a
Negative.
negative, yes.
How do we understand the difference between a minus and a negative?
I like to think of, a minus sign does mean subtraction, okay? But adding a negative number is the same thing as subtracting.
Oh.
So when I look at each term, if there is a minus in front of it, that's like a name tag that coefficient is negative, okay? That's kind of how I think of it. So when I'm in my calculator, I'm using that negative button, but you're always adding between. Does that make sense? It's kind of trippy, but I think that's the easiest way is if I see like this has a minus, that means this is negative. Minus sign, this guy's negative. Minus sign, this guy's negative. It's just kind of telling me that that's a negative coefficient for calculator typing purposes. Okay? But this one I think is tricky because they put the constant in the front. So y'all had no problem telling me right here that this plus 4 we just drop down and deal with later. So even though this guy's in the front, I'm just going to drop that negative 4 right now because it's not attached to parentheses. It's that negative 1, and I had to be kind of creative and write that negative 1 in. So that's a big deal. So I'm really only distributing a negative 1 here and here. Okay? I see stuff like this in STAR questions all the time. And it is trippy. It tricks my Algebra 2 students sometimes. So you got to be, I like writing that 1 in there so I know what I'm multiplying. So what is negative 1 times positive 1? Right here. Negative 1 times positive 1 is?
Negative 1.
Negative 1. Negative 1 times negative 6p. There's that negative times a negative. Makes a positive
6.
6p. Remember when we distribute, we're multiplying. Negative 1 times negative 6. Throw in your calculator if you need to. Positive 6. Kind of like number 8. Are we finished?
No.
Because I got these guys. My two constants. Want to put those together? Negative 4 plus negative 1 or negative 4 minus 1. What does that combine to be? You can only combine these two.
-5.
Negative 5.
Yeah.
And then drop down the plus 6p. Nothing to do with that 6p.
Wait, when it creating 2 negatives, does it make a positive?
Okay, you got it, Coach.
That's if you're multiplying.
Okay, so I want you guys to try to finish the rest of this page, and I think there's like 4 problems on the next page. When you finish that, I have this paper here. Since we don't have our Chromebooks yet, we got this paper that we're going to work on. I have an answer key. Hopefully my answer key is right. I was chasing my 2-year-old while I was making that, so y'all will know. Y'all will catch my mistakes if I have any. And then when you're finished, you can put your calculator up, and we will get the phones back. It's 10:03. I will get your phones back at 10:20 so we can do my little form. And then if anyone needs help knowing where they're going next, we got that. So finish the practice on page 2 and 3. Show me when you're done. You can pick up this paper. Ready, set.